Grrr, né? Oh, continue is there. Let's draw. Hi, natural. Excusez-moi. Quite possible. Well, YouTube, I don't know. You can learn anything from the internet, especially coding. Well, just have to duplicate these constants, I'm afraid. I just need the first three. Yep. Okay, so I have something that is this parabola, which is also a parabola. And then around 0, it quickly turns into another parabola. It stays like that. Let me cut it off at -10 because I'm not going to use this side for now. Well, that fits completely. I need a bigger deviation actually. We should add some sliders so I can tune stuff. I guess that's what I should do. Okay. Let's begin with adding a single slider, which I completely forgot how to do that. So hopefully a slider exists. It doesn't. That's unlikely. Slider exists. Okay, can do a create slider. Let's use this as example. Right, then I have this as value. From 0 to 1, but nothing changes obviously. Right, that seems to work. But I want this thing to be actually equal to that one. Oh yeah, no, it started -10. Right. Yeah, okay, good enough. I do wonder, I probably should just allow me to change everything. A is 15 at the moment, and the other is 3.1. Oh, now all the slides are on top of each other. And I did not dig on this yet. Well, according with Sheathan. The coughing has started again. Yeah. How long have I coding in C++? It's almost 30 years, I think. Oh God, let's say 30 years. I'm using new Vim. Okay, how can I make these things not overlap? I'm gonna guess that this is the X value. What about 50? Plus 50, what is it? Minus 50 actually. And then these two, of course. Is 8. Yeah, my thing is on GitHub. I'm really trying to code here myself, but whoop. Download. Oh, there's only one A. Well, let's call it A then. Why would there be only one A actually? Okay, I want more than one A. Let's make more than one A. No, I'm not so sure. I'm not sure at all. But let's do it anyway. So I'm gonna make an A2. Duplicate this. For A2. Don't look outside while typing. I said A2 minus A1. I'm sigmoid, okay. Now, let's move all three somewhere over here actually. So this is from here to there is 100, 100, 200, 300, 400. Shall I subtract 500? Do we dare to subtract 500? I think so. Minus 500 is 3, 4, 4. Okay, let's see. Ugly, yeah. I shouldn't really change that, indeed. Could you get such a horrible nick here. Probably should be the same as the other parabola. But what about this one? Oh, see, not that bad. There's a little undershoot here, which is interesting. So now maybe you want to... probably not. Although we got D Jorum. Yeah, the reason that A has to be the same value is because I'm going from one parabola to the other at W equals 0. But it's doing that in about this range from here to there. So there is a deviation here, which maybe not the super nice straight line. Steep parabola. I just need some fixed values, I think, to test with. This is no good, so I need something like, I don't know. Yeah, this looks good. I think we can test it with this. No, I don't know. Maybe. Maybe try that. Now I might as well go from -4 here. I better write down these values. A1 is now 14.2, 3.52 and 0. Okay, I can't remember that. 3.2, 3.52 and 0.68. So those are just the defaults that I'll use because I like those values. 14.2, 52, and 0.608, and then we start the whole thing at also from -4. Right, okay, now the idea is that if I start, let's say, at 4, and I take another sample at 3, then we will find this blue parabola, which then goes, yeah, maybe I should draw that as well. Let me draw a green parabola below this one. I have no suggestions. Let's draw. Let's draw this one on top, maybe. And then I'm gonna draw parabola 1, parabola 2. using all the two values. That should work if I at least set the values. Yeah, no, I don't want this. Let's not use. Let's just not use sliders for that. I'm just going to use B2 and stuff. Just a fixed constant A2 and B2 and C2. It should be these values. Mm-hmm. What? What? Oh no, this one red actually. Green I said. No, I said red, but I typed green and I meant green. It didn't get drawn though. Oh, that's because I'm moving. The wrong parabola. Oh, that should work. It's probably drawing it twice or something. Yay. Okay, so we have two parabolas, the green one and the red one. And over here, the curve that I have, which is the formula you can see here, well, you can't because it's too wide, but that's equal to this parabola, and then around W equals 0, it changes away from green here, and then it starts following red. It's very contrived, but well, I want to test with this. And the idea is now that we're going to fit a parabola at these points, and then of course find the green parabola. And having found the green parabola, we're going to jump to the vertex of the green parabola, which is all the way down here outside what we can see. Damn it. Yeah, maybe I do need a few sliders for green as well. I think this jump is ridiculous. Okay, let's just add more sliders. It's always easier. Sliders after all. Wait, I'm trying. I'm really trying. Dot value. Yeah. Duplicate all of this. So much. And then substitute. Oh my god. I can just do. Wait a minute. What am I doing? Oh yeah. Okay. Sorry. A, B, or C. Followed by well, 1. Replace with pixel is 1. 2. Lovely. Is that all? Could have done it manually. Well, not quite, because this should be plus 100, I think. Sorry, plus 100 over there. To 500. Let's make this 600. And this also. And then this is 600. 600. 500. And then the default value should be P2 and C2. Very good. Okay. 14.6, 3.15 and 0.451. Then I can subtract these two parabola from each other and plot the difference, which is again a parabola. Now let's do some math. That was all fun, but in the end you just need to do math, right? Okay, let f be a plus b. This is a bit hard to work with though. I think I'm better off by specifically defining the vertex. So the vertex is now at this difficult value. What do I just replace that with v? Okay, I started with like this because that's how I stored. The derivative is then that. From it follows that the vertex is at, just set this to 0 and solve for x. So the vertex is that. Let's see now, okay, maybe x is v, or let's give this a value as well. A different name, I mean. Like the B of base or something. It's the bottom of the vertex. But I used E. I used B already, so let's set to E, which stands for extreme. Yeah, because it could also be a maximum, right? Depending on the sign of C. We wrote in terms of x minus v. I think it's just x minus v squared plus e. If x equals v, so we are in the vertex, then the value was e. That's the value of the extreme. And also, if x equals v, well, that's where the vertex is, so yeah. Then the derivative is 0. Am I missing something? So suddenly only 2 variables, so... I should go to bed real soon. I think I'm sick. Like, seriously getting sick. I just pained my throat and then it went slowly away, and then I started streaming and talking and eating peanuts, and now my throat is working up again. Feeling tired as well. I don't know. Not going very well. Let's make some tea. Yeah, I just gave you a link with everything you need, Ethan. Just put more effort into it. Even if it takes you a day, don't give up. Let me check if this is correct. So let's try it like this, and I'll fill in these variables. E is this, plus x minus v, which is this, all squared, is the same thing, plus yeah, x plus that squared, so that would be x squared. Can't be right here. There's definitely a C missing here. I think there's just a C here missing. Let's try that then. Add a C there, add a C there. So then we get the same thing, plus, and then C, dude, C times x squared, and then this was a plus, and to do that squared times C, so plus b squared divided by 4c squared, but then times c, so divided by 4c, plus 2 times x times this, which is just b divided by c, but then times c, so that is b times x. Yep, and that drops away against that. So this is indeed now equal to this. Right, well, back to 3 variables, that's better. Okay, say the vertex at v, and then put that below here. So vertically from the vertex, meaning that fx is h larger than e. So this is just now E. Or H has the same sign as C. That is, if C is larger than 0, then it is a minimum. So E is the minimum, and then H is positive. And if C is less than 0, then it was a maximum. So E is here, and then H is negative if you add it like that. At that distance, the half width not super heavy calling it HW. This looks like two variables. Maybe we should use call it S already, the S of scale. But this becomes a lot easier with this formula. Let's rewrite that. So V plus S, it doesn't really matter if we add or subtract S, right? When the parabola is symmetric. And both plus and minus S, left and right of V will have, F will have the same value. So, and that is equal to well, by definition, S is basically defined by this. So at S, all the word defined somewhere. So it isn't H. So the scale is defined as that you have to deviate left or right from the vertex. That amount in order to get H above or below the extreme value. Or E is the Y value of F. For F, E is the F of V, of course. Right, and then we fill in S. So this now becomes this one, where X equals V plus S. From which follows therefore that E plus H equals, this might well continue with an equals. Equals, I need to enter this. How do we do that? Oh, we're already there. That's what I mean. E plus CS squared. From which follows that so the E drops out, of course, and then you just have left H equals CS squared. So yeah, this was a lot easier than with working with that formula. From which then follows that S is the square root of H divided by C. In other words, if we fit if we fit the red, no, we fit the green parabola, the vertex is like here. And if we decide that the scale is equal from here till there, then this from here to there is S. Then from here to there, the bottom is H. And the reason that we picked this point is because this is the data point that we use to fit this parabola. That is the furthest away from the vertex. Sneeze. I think this value kind of belongs to the scale. So at some point I do calculate a scale, and at that moment I also know this horizontal distance. Well, because that is the scale. I think I should remember the parabola and the scale, and then we have everything, because if I have the parabola, I have the vertex. If I have the vertex and the scale, then I know. Well, I still don't know if it's on the left or the right side though, where the data point is then. So maybe store the scale as a positive or negative value. Like literally positive if it is on that side and negative if it's on the other side. And then the height is also positive or negative. The height is then the difference from, so you fill in S, you fill in V plus S into the parabola, and you get some value, and then you subtract the value E from that, and that gives H. Probably should make a class of this. So then I have my, some parabola plus a scale, which can be positive or negative. And then we do something and we find a different parabola. And that different parabola then should be used to adjust the scale. So in this case, the new parabola we found is the red one. So the vertex is shifted. The extreme is almost the same in this case, the height. And yeah, then I can look at this distance, vertical distance, which has a maximum here. This difference is 0 here, maximum here, 0 here, and then it gets larger and larger and larger again. And what I want to find is the point where that distance becomes larger for the first time, larger than 10% of the previous age, I think. No, not previous age, where it becomes larger than 10% of the value above E at that point. Above or below. The big problem here is that there are so many possibilities. Like, it can be a minimum, it can be a maximum, or it can be left of it, it can be right of it. The vertex can be shifted to left, or it can be shifted to right. C can be larger than 0, or C can have been increased, or C can have been decreased. And then actually finding that point, it can be here. Let's say this is small distance. It's quite possible that, what do I say, quite possible? It's like totally the case, of course, that here, I mean, this is E. That deviation here is like way larger than 10% of this height. It's like 50% difference between this one and this one. Okay, wait a minute. The thing is that I have to assume that close to the vertex, the new problem is better. So I start with the green one. Then I'm not really interested in the green one because we switched to the red one anyway. So here I'm like, okay, red. And I'm continuing with red at the very least up till the point where my data point was. No, yeah, that was there. Oh shit, so the data point is on the other side. I have to mirror that in the current... okay, yeah. Not good, right? Okay, the scale is not that important. It just must make sense. I think it might make sense to go probably to the point where they're equal again. So I just want to know when beyond this point here, the distance becomes too large relative to this height. Which in this case is like way beyond the previous data point. So I would keep the same scale. Which is reasonable, I think. It's reasonable, you know. So the scale would stay something like 5 or 6. And then the next parabola is probably did not change at all. So this distance never becomes large, so I just always keep the same scale. While if, say, they are very different, that's kind of ridiculous, but it just doesn't make sense to have something like this. So really, I need to keep it like that. Okay, the vertex of the green one now is about here, and the red one about there. So not that much difference. But if you started with this one, with a, say we have a data point here with a scale of 1, 2, 3, 5, 6, and then we find the red one, and I said I'm going to at least go to this point, then comparing with this height, at this point the deviation is already larger than 10%. Yeah. So I want to throw away these data points. And I think I will set the scale to, let's say, here. So something like 3.5 or something. Instead of 6. Yeah, lots of works, but it's 10 p.m. and this is my bedtime these days, and certainly when I'm sick. I'll have to think about this more. So I'm going to go to bed. Well, no, I can't go to bed, but I will. No, I will go to bed. Just one game of chess, okay? Just one quick game of chess. Look, I have a rating of 2000. I'm getting stronger. It's complicated, Clement. Okay, this is Spanish, isn't it? Guadalupe. What should I do here? I threaten to take the knight and then take this pawn. Okay, so he does that. I can push my pawn 2 squares. That can't be bad, but this is also a very reasonable move, although maybe not. Okay, he takes, I take back, so my queen is overloaded. You take, I take, he takes, I take, he takes there. And then I lost a pawn. Okay, let's seriously have to defend this. Yeah, he's going to castle, and then that one comes into picture as well. I could take it first now, and he takes back, and then defend my pawn. But I don't think this double pawn is a weakness, really. Let's keep my bishop. I like my bishop. I'm going to play this one, I think. That one has to participate as well. Okay, now the knight in the Rue de Lopin, the knight goes like here, there, there, there. So after he castled, and he even made an extra weakness. So who am I to say no? And the bishop kind of belongs here. So suddenly, you know, after all these pawns go away. Maybe I should put my bishop here. Okay, we're heading to c2. So I do now this, and he takes, and I can take back with tempo more or less. Oh, wait a minute, he has a knight going here as well. Oh, nobody likes that. And so I'm gonna do this anyway, I think. Now I'm kind of threatening to push this pawn again. Which can't be wrong, right? I have to move the bishop back as well. Maybe here though. I have not decided yet. Please move the queen so I can take a pawn. No, he doesn't want to. Okay, now I go here, I think. I can just take with the pawn. And then keep him out of that square. Yeah, I'm gonna have to take, right? Otherwise it's stiff. And now if he pushes, then it's again kind of soggy. It's kind of soggy. Plus I need my pawn here, otherwise the whole knight routing didn't make sense. Yeah, I don't want to give this pawn away. I just don't. Well, I could have moved to the side. Yeah, I could have done that. And then if he would have taken it, just a rook here and win that pawn back. Although he goes to the side, taking my bishop. Yeah, nah. Maybe this is better. After all. Right, that doesn't threaten anything. It's very nice for you to have the knight there, but who cares? See if I care. There is no king I take left without queens. So I'm gonna have to win with this free pawn on the queen side. But why did... Oh, he's taking that not because of this. Okay, he's trying to take here and then take back, and then I lose that one. So maybe I should go here. Defend my pawn. Oops. Motherfucker. Why do I always give my games away like that? Why? Why? Not good at all. Not good. I want to go there, my knight. How do I get there? That's a lot of moves again. He's going to double. I can't stop him anyway. It's too late to stop him now. Yeah. Let's avoid the check there. One more move and he can't get in. Well, he can go here with the rook. Oh, this is worse. Oh, no, I moved the rook forward actually. It's not even that bad. And he has to move down there anyway. Yep, I have to take with the bishop because otherwise I lose this pawn. You know, we can play the knight. Would be better to play the bishop back first, maybe. It's already doing it. Yeah, going there anyway, I think. On second thought, I should have gone. I should have gone, oh, like that. Oh, like that. Sure. Nothing works. I'm delaying the whole moving my free pawn forward a bit long. Am I not? Am I not? Yeah, now that. I really wanted to check it again. To go. Oh, fuck. I should have first taken it. No. No, I'm so lost. Now I'm really totally lost. Like, totally lost. As if I wasn't lost before. Okay, let's give that one away. Yep. What about this? Oh, my bishop is attacked. Okay. Maybe I should have gone there to protect this pawn though. Oh, is the pawn forward? Pawn comes forward and I give up. right, okay. Well, maybe I win on time. You never know. I think it's time to check there. And then go here. You can't check me. You can't check me. I have the strongest bishop on earth. There has never been a stronger bishop. Oh shit, he can't check me. I'll take it anyway. Tempo. Fuck. We have nothing left except the clock. We're going to win by clock. Oh, or not. What? Seriously, this dude is right. He's just going to win this. Totally going to win this. Totally. Totally. Maybe it's a draw. You know, stalemate. Okay, so I'm gonna go here and then he's running out of time, so he is very no, he's not. I hoped he would be nervous. Yep. Okay, I have to go there, otherwise it's mate. No, he's defending it. He's going to get a second queen. Good for him. Okay, stalemate. Oh, there's a mate. Okay, yeah, I knew I should have gone to bed. -7, no 2000 anymore. Tja.